Oh yeah. So, hello everybody. We're talking about dependency proxy feature. Yeah, it was implemented long ago, maybe a year ago. But so I realized before doing this presentation, I realized that we need to discuss some concepts. So let's start far from the beginning. Which abstractions do we have in Workhorse, and why this feature was implemented in a particular way? Yeah. So maybe let me share my screen. So which abstractions do we have in the Workhorse? For example, one of them is called Injectors. Workhorse, it acts like a proxy for GitLab Rails. It's either propagates requests or performs API requests on its own to the GitLab Rails, and then performs particular operations on the information that is received from GitLab Rails. Yeah, and all the requests come through the Workhorse. And for example, one of the abstractions that we are using, it's called Injectors. Yeah, sometimes it's spelled with E, sometimes with O. I don't know, but yeah, for example, Injectors, how it works. A client sends a request to Workhorse. Workhorse propagates the request to Rails, and Rails responds with a particular header that tells how to process the request. Yeah, and then the Workhorse sends a response based on the header received from GitLab Rails. A useful example for us would be the way how we send a git blob. Yeah, it allows us to avoid sending chunks of the huge blob, for example, through the Rails part. For example, a client requests a blob from Workhorse and GitLab Rails. Workhorse propagates the request. Rails responds with a git blob header with some encoded data in it, which blob and also the limit, for example. Workhorse established connection with Gitly to perform get blob RPC. Then Gitly streams the data to Workhorse. Workhorse streams the data to the user. So a huge chunk of information comes avoids coming to the Rails and being processed by Rails, which is cool. And actually, maybe some deep dive into the code. When the request comes to Rails, for example, this API request for a raw file, we send the header using this send git blob method.
Igor, could you just show the file name and the path, please?
Full name? You mean this one? Or
what file are you in? Oh, sorry, lib API files.ib.
Yeah,
okay, sorry.
It's here. Yeah,
Gotcha.
So this one, and the implementation of this method is basically like sending the header and encoding some parameters. It's like repository, ID of the blob, and the limit. How it's implemented on the Workhorse. Workhorse builds a proxy, which actually processes every request. It has the access to request and response, and we specified a list of how we call them injectors. Yeah, so we can either current implementations. Yeah, send in a blob, send in a div, patch archive, and something else. Then we iterate over all the injectors and see whether we can find a match in the header. When it's found, we call the inject method. And for example, for a blob, it's performing a blob request to Gitly and sending the blob to the client. So it's just, I decided that maybe this information is useful for our team, so I decided to use this example, but The most common example is sending, for example, a file, how user can download a file from the object storage. It's pretty much the same. We have object storage instead of GitLab here. So, and then the abstractions that we have, or maybe do you have the questions regarding exactly this part? Maybe let me stop here. Yeah, sure.
I know this should be apparent to everyone, but is the reason that we have Workhorse in the first place is because it's written in Go, and so it's directly taking a request from Nginx and essentially deciding if it should bypass Rails or not.
Yeah, it's actually to handle like long running requests, and we have a blog post which is called brief history of GitLab Workhorse. I think let's say it's recommended read because it contains like a history or why we've introduced the Workhorse, with also with details how it was how it worked in the first place, and how it was extended, and why we've decided to propagate all the requests through it. So this blog post contains all the data and all the names, all the heroes that implemented, people who implemented the Workhorse and contributed in it. So yeah, I think it's better to send you the link to rather than explain it.
And the two examples that you gave, object storage and GitLab.
Yeah.
So in both of those cases, Workhorse, based on the headers that comes back from Rails, will decide I can just access GitLab directly, or I can just access object storage directly.
Yeah, basically saying but like Workhorse actually controls this connection and sending the data.
Right.
So cool. Then we also have an abstraction which is called Preauthorized requests. It's usually used for uploading the files. And for example, client requests to upload the file, and Workhorse performs authorization request. For example, request is authorized successfully. Workhorse upload the file to the object storage, success, and then the Workhorse finalized the request. Finalized the request, the upload. It just creates a database record. So the whole file also misses the Rails. We don't process the huge files in Rails server. So for this one, we actually have the documentation. For injectors, we don't have. Maybe I'll fix it later. Because actually, as far as I remember, I couldn't find any examples or documentation. So maybe we can fix it. So there are some docs to read how to actually implement a new uploader, add a new uploader. So for this one, I don't have an example, because for dependency proxy we'll see one. So for dependency proxy, why this feature was actually introduced in the first place? It's like optimization for example, for containers. When we pull a Docker container, we rely on the external container registry, and in order to mitigate the risk, make it less risky, mitigate the risk and reduce the reliance on the external component, we cache the file in the object storage, and also it also accelerates the access to that file. So when it actually works like a cache, when we try to pull a Docker container, if it's not in our object storage, we download it from container registry. If it's there, we just stream the file to the user, and everything is fine. So it actually works like this: request for a file and respond it with a send URL injector. If the file is in cache. If it's not in cache, we download the file, upload the file, only then and only then we respond with the file. The problem with that approach is that For example, I believe it was introduced when we even used Unicorn, and with Unicorn it was even catastrophic because it could block other requests. Long-running HTTP request could block other requests, and so for Unicorn it wasn't even. I believe it was forbidden for usage, and dependency proxy feature was only available for Puma servers. But even for Puma, it's not recommended to serve long-running HTTP requests. That's why we decided to move it to Workhorse. And the problem with it, with existing abstractions, that the existing abstractions didn't fit to any of them, didn't fit to the dependency proxy feature and implementation. For example, with injectors, when we request a file and when we try to pull a container and we actually have this container cached, we don't have a problem with injectors because we just respond, we send URL injector header and everything is fine. But if the container isn't cached, we need to save it. Yeah. And for example, it isn't cached. We respond with Rails that we don't have this file cached. So now we need to upload it to object storage. It's not a problem for Workhorse. We start uploading it to object storage. The problem is that after we uploaded it, we need to finalize it to create a database record in the GitLab Rails. So we need some custom logic to perform a finalized request to Rails. So it's possible, but not so elegant because we also need to have authentication data to finalize the request. So it wasn't so elegant. For preauthorized request, it's straightforward with uploading the file, but for responding with a cached file, the problem is the same. For example, we are here and we have for example, we've received this information with authorization request that the file is actually cached. So here we need somehow to provide the logic to respond. We respond with the file that is actually cached. So yeah, long story short, all the existing abstractions wasn't a good fit for the dependency proxy. So we've decided to come up with a new approach. And this is a diagram for this approach. So with for example, when we have the file cached, when the user requests for a dependency for a container, we propagate this request to Rails. Rails checks the database, whether the block persisted in the cache. And if it is, it responds with an injector, everything works fine. But if it doesn't exist in the cache, in the object registry, we respond with a new send dependency injector. And Workhorse recognizes this send dependency injector. And if we simplify the logic, I would say that we send Workhorse sends a request to itself. It has a file to upload, and now it just sends a request to itself to upload the file. And all the existing logic for uploading the file, preauthorized request, is just already there. So we just perform an external request to Workhorse itself to upload the file that we downloaded from container registry. So I agree that it's confusing. Maybe let's go over the code. Maybe it will clarify the things a bit. For example, when we receive the request, so we have this blob wire workhorse behind the feature flag. When we receive this request, we try to find the blob in the database. If it's present, we send the blob. Everything is straightforward. But if it's not there, we send the new dependency header like this. Then we've implemented a new injector in the workhorse and started to process this new request. So if the file was cached, that's not our problem anymore. Now we want to fetch the file from the container registry and send it to the user. Oh, sorry, I missed the part that with this send dependency header, we also send authorization data and the URL to download the file. So all the data required to download the file and send it to the user. In this method injector, we fetch the URL, we fetch the data from the container registry, and then we send it to the user and upload it to the object storage simultaneously. And this is actually the cool part. We're using the T reader here. So the interesting part that is it's a Go method from standard library that receives that actually we can pass a reader there and a writer there. So and receive a new reader. So when we read from this reader, we actually receive the data from this reader and write the data to this writer. And it's actually, the data is actually streamed. I don't remember the default buffer size, but for example, when we read 4 kilobytes from this reader, 4 kilobytes from this reader is read, and 4 kilobytes are written to this writer. Actually, I thought that this was the word tea, like a drink, yeah. So I thought that I had an analogy in my head that it's something like this. You know, when you try to spill some tea in a cup, and then this part falls down, and everything is spilled. And yeah, I thought it's an elegant solution to stream the data, but I believe that actually this word means this part. And so when we receive a reader here, we receive the same data here, but the data is also written here. So
and it's the same as the Unix command.
Oh yeah, and it's also called the same there. Yeah, so sounds reasonable. And yeah, so this is what I actually liked, that we can simultaneously stream the data to the user and also upload the data to the object storage. So we don't have the delay. User doesn't wait until we upload the file to the storage and then starts receiving some data. So this was the interesting part, and also I enjoyed reading the feature spec. It turned out that we don't run Workhorse for our feature specs, and in order to make sure that Workhorse is running, we need to specify like JS as if it's like a feature spec that that performs some request to browser. And yeah, with this part, we could run the Workhorse server and make sure that our feature works with feature flag enabled and without it. So like this feature works like it worked before. So yeah, this part And I believe that is it. Maybe if you have some questions, I'll try to answer them.
Yeah, I do. So from my understanding, after you've returned the data back to the client, you should also be writing to the database to store that it's been cached. How does that happen? Yeah,
thanks a lot for this question. That actually I missed I missed this part out. So remember I mentioned like pre-authorized requests, yeah? So let me check. It's actually here. So we actually built, now we have this T reader. We send a response body that we received from container registry. We specified clients end to client. We plan to write some data to the client. And now we have this reader. It's like a body that we want to upload. So we actually like build a request. I'm sorry, just a second. Yeah, we actually build a request and send it to the Workhorse itself. And now Workhorse just processes this data and this request using its existing abstractions, which is called like preauthorized requests. For this one, we need to implement 2 endpoints on GitLab Rails, one for authorization and one for actually finalizing the request. So Workhorse performs authorization request. With this endpoint, we provide all the data, and we provide all the data required to like perform this request. And with the upload endpoint, we finalize the data. We create the database record and respond that everything is fine. And Workhorse then understand that the request completed successfully, and yeah, and that's all.
So the writer from here is the one that's sending the request to the Rails, the Workhorse endpoint you just showed.
I would say that not the writer. The writer here sends a request, sends the response to a client, to the user,
to the client,
with a file that it downloads. The Rails part is processed with the existing abstractions. So we have this upload handler. We actually injected it from another part of our code base with this one, which is called body uploader. And body uploader is the existing part. Let me quickly check whether it still exists. It doesn't exist anymore. I'm sorry, but yeah, actually what it did, it just took the body and uploaded it. So it's like a simple upload request by a user. It's like uploading a simple file. So we just constructed a request and uploaded it to the object storage using our existing abstractions. So and this body uploader actually performed the authorized request and finalized request. So yeah, but maybe yeah, I need to provide some documentation on this part because I won't be able to explain. So I deliberately skipped this part because it's also complex and requires an external, a separate explanation, I think.
Yeah. So we are on time. However, if we want to continue, I have time afterwards to if people have more questions. I have one actually. Does everyone have a bit of time to continue this call if they have more questions? Or does anyone have any more questions? Yeah, okay. So my question is, again, this is also just confirming something I think is true, which is Workhorse doesn't have any direct access to the Postgres database. Everything is through Rails endpoints, right? It has to always make a request to Rails.
That's true. That's true.
That was my question.
Yeah, and all the information, is received via HTTP requests to Rails part.
So I have a couple of questions. I was curious to learn about this T-reader. Looks pretty cool. And my question was like how it handles the error handling. Let's say one of these processes like uploading of the, let's say uploading to the object store fails while we still sending streaming data to the user. Are they kind of independent or one breaks another one?
So yeah, if we receive an error, so let us check the documentation. I think probably yeah. So any error encountered while writing is reported as a read error. So if we fail to send a user the request, the response, we fail to finalize the request as well, as far as I know. Yeah, or maybe we've implemented it differently. So maybe this part I forgot because for some reason we've provided the null response writer, but at the moment I forgot the reason why we've decided to do it. Maybe actually to handle this issue that you mentioned. But yeah, but for T-reader, if we encountered any error with the writing, we report an error.
Sorry, just go back to that. So that's why I asked if the W is the part that we're uploading, this writer here, is the part that we're using to actually upload the file, because in the docs there it says if the write must complete before the read. So my understanding is that we're sending the whole response back to the client before we finished writing that file to Rails, which in my mind it should be the other way around. Like the write to Rails is the more important thing. Like we need to make sure that succeeds before we send the data back. Is that incorrect?
I think yeah I recall this part. I think that writing the data to the user is more important. Yeah, if for example if we failed to upload the file to Rails, it's fine. It's like like failing to write to the cache. Yeah, it's we'll try to cache it next time. So and actually we made sure that if we fail to write, we don't fail sending this data to the user, because user shouldn't care about whether we've been able to cache it or not. So I believe that's actually why we introduced this null response writer.
Makes sense.
Thank you. I also have a question. It's a bit not related to this topic, but it's when you were showing us the interaction between the Workhorse and let's say GitLab. The Workhorse makes like direct request to GitLab. I think after verifying that the user has an access to that, like through the Rails permissions check. Like from the security point of view, I'm just like curious if you know any like how it's done, how we permit that, let's say how we prevent that verify that Workhorse is like verified the data before actually going to GitLab, or like.
So I believe it's just like streaming the data. It's like Workhorse establish a connection with GitLab. And just stream the data from the GitLab, and then stream the data to the user. It's not like connecting a user with GitLab. It's mostly like acting as a mediator. So it's I think from security point of view it should be fine.
Thanks.
But maybe when we stop sharing, there's one Easter egg.
Any more questions?
So maybe it was a bad style to finish the video, because it's like a cliffhanger. Yeah.
Well, we can stop the recording now if that's a good idea.
I mean, a cliffhanger for anyone who is watching this video. But yeah, thanks everyone for watching. Yeah. So
Igor, thank you so much. That was really, really awesome. A really, really great presentation. The documentation you produced, did you produce all that for this, or you've got it from other areas and put it together?
No, I produced it now, and actually it's not like documentation. It's just a description in some issues that I've created. Yeah, so just to be able to make Markdown. Yeah,
looks amazing. Thank you so much. I'm going to stop the recording unless anyone else has any last points. Okay, stop the recording.